Morning girls. So one last thing we need to do in complex numbers is going from polar form back into rectangular form. Okay, so you can see what we're going to do here today. So writing complex numbers in the from polar form back into rectangular form. Now what rectangular form is your run-of-the-mill a plus ba form. Okay, so just a normal complex number. So we'll start with this example here. So you'll need the polar number. This will be given to you in the question. I'd quickly jot down an Argand diagram, okay, and you're also going to need your page 13 of your logbooks. Okay, so let's get started. So you can see here we've got 2 times cos pi over 4 times 5 plus sine of pi over 4 times 5. Now, this 5 is only a multiplier. The main fraction is pi over 4 and it's been multiplied by 5. So keeping that in mind, we're going to go straight to our page 13. Okay, so we're looking for pi over 4 because that's what we have in the question. Then from that, we need to look for the cos value of it, which is 1 over root 2, and the sine value of it, which is also 1 over root 2. Now, they're not always the same. It's just in this example here. So 1 over root 2, 1 over root 2. Okay. So now I can start to rewrite this. So instead of cos over pi over 4 times 5, I can replace that now with 1 over root 2 plus a, and we've seen that the sine of pi over 4 was also 1 over root 2. Now, we're nearly there. All it's left to do is multiply these out. Okay, so we've got 2 times 1 over root 2, which is 2 over root 2, plus a 2 times 1 over root 2 again is 2 over root 2. Okay, so we're nearly there. So from here now, 1 or 2 more things left to do is we need to figure out if these are positive or minus, depending where this number would roughly lie on our Argand diagram. So if we bring you back to our page 13, you can see we're dealing with pi over 4 here. That's 45 degrees. Okay, so 45 degrees. So what you might be thinking is, off we go and draw on a triangle of pi over 45 degrees. That would be correct if it wasn't for this 5. Okay, so remember this 5 is a multiplier. So it's pi over 4 is the 45 degrees multiplied by 5. Okay, so 45 times 5. You use your calculator to help you. 45 times 5 equals, 225. So it's actually 225 degrees because of this 5 multiplier. So it's not this. This would be incorrect. So you need to go 90, 180. So it's 225, which is roughly about here. So you can see that this 5 being multiplied by the pi over 4 takes us into a totally different quadrant. So then remember, make your triangle always has to go to the x-axis. That's 90 degrees. Now, this is 225 degrees. Okay, so now you're not really concerned here about finding the argument or anything. You could if you wanted to, but all you want to see is what quadrant your triangle sits in. Okay, so because of the 5 being beside the pi over 4, what you might think was this is actually down here. Okay, and remember down here, you're down in the minuses, so this is the minus quadrant. So that makes this a minus, and it also makes this a minus. Okay, so I'm just going to rewrite this a little second. to put the minuses in. Could go plus there. I'm just going to put the imaginary a there after. Okay, so that is us now. Very close. Okay, so remember we want it in a plus ba form. Okay, so we've got the general just there. But if we multiply by the denominators here, we could get it into single format, okay, of a plus ba. Now it won't always work. Sometimes you're just going to get a fraction, but here I think it will. So we've got root 2 as their denominators, and they match, which allows us to do this. So if I multiply everything top and bottom by root 2 here, hopefully that'll help us simplify down into this form. So if we multiply this times root 2, so this by root 2, this by root 2, I should get root 2, and then again if I multiply this by root 2 and this by root 2, that'll leave me with just root 2. So then I've got my minus and minus because of where it falls on my Argand diagram. It's now in a plus ba form, which is what we want. This is rectangular form. Okay, so if you stopped here, that's fine. Let's just always see if you can simplify. So the denominators here were the same. We're dealing with 2's and root 2's. So I spotted we could simplify. Okay, so that's one example. Okay, so we'll do another one. Okay, so here we've got another one. So we've got cos 7 pi over 6. Now remember, that 7's a multiplier. We're looking for the pi over 6. Pi over 6. So again, I'm going straight here, looking to see if I have, and we do, pi over 6. So I can now replace cos of a with root 3 over 2 and sine of a half. Okay, so I can now replace cos with, so the root 3 on the outside stays the same. So now cos of pi over 6 is root 3 over 2 plus a, and sine of pi over 6 was a half. Okay, so start to take shape. So remember, this 7's a multiplier, and that's going to help us find out where in the Argand diagram our triangle would lie. So then it can tell us if these are minuses or pluses. Okay, so back here we go, just to show you. So we're dealing with pi over 6 this time, which is 30 degrees. Okay, so 30 degrees. However, look, pi over 6 is 30 degrees being times by 7. So 7 times 30, so again get the calculator if you want, or 7 times 30 is 210 degrees. So if we go here, we've got 90, 180, 210, which is roughly there. Okay, so this is roughly our 210 mark. So again, you're not really interested in angles here. We just want to see where it lies, and it lies here. Okay, so it's in the minus. Okay, we're down below, we're in the minus parts. Okay, so that means then over here now, I know that this is going to be minus, and I know this is going to be minus. So I can start putting all that together now. So we'll take a bit at a time. So now I know this is minus, and I now know that this is a minus. Okay, so I'm just putting a behind it, because that's usually where it goes in rectangular form. Okay, so now I know the values, I know where it lies in my Argand diagram, I know the pi over 6, cos is this, sine is this. So now all left to do is multiply this by root 3, this by root 3, and that should give me directly to rectangular form. So use your calculator, type in your calculator root 3 multiplied by root 3 over 2, okay, and you should get minus 3 over 2. And again, into your calculator, root 3 multiplied by half, and you should get root 3 over 2. Remember, that's our imaginary part, so that's our I. And that's us now back into rectangular form. So this is us A plus BA, or rectangular form. Now, here, again, if you wanted to, you could, like we did over here, get it into singular form, okay? But again, that is the answer, the same as over here is the answer. All right, so I will take a picture of this and put it up, okay? So you can see how you get on. And this is what the questions are going to be based on for today. Okay, so I'll write up what page and all they're on to. Questions 6 and 7 anyway. And I think it's, let me double check here. Page 306. Okay, so I'll write up which ones I want you to have a go at. Let me know if you need any help. Okay, just email me or comment on Google Classroom. I'll get back to you as soon as I can. Thank you.